Hi everyone. So in this video my plan is to discuss a graph where we'll try to find out the increasing, decreasing, then local maximum, minimum, then domain range, most of the thing from a graph. Okay. So I have a graph here. If you can see, let's keep the graph side by side so that we can discuss it. Okay. Oh, okay. I think this is the best. This is the way I can show you. Okay, look, this is not the ideal situation, but still let me try to explain. So do you see there is some arrow sign here, downside arrow sign here? Let me draw it here for you, but their graph is nice. Okay, so we'll discuss it from there. Just to this is going through this, then again this way, then somewhat going down, then again this way. So there is arrow sign here, then there is arrow sign here. Okay, I think this will also help us a little bit. X, Y. Okay, so there is an arrow sign here, there is arrow sign here. First notice this thing, there is arrow sign here, there is arrow sign there. So when it is some arrow sign this side and that side, what does it mean? It means actually from this graph we will get local maximum and minimum from this kind of graph when there is the graph is open interval. Okay, so let's try to find out the domain first from this graph. Domain. Okay, so domain is what? Look at this graph. Although we do not have the equation of this graph, but the general trend shows the graph is going this side forever, the graph is going that side forever also. See, the graph is going this side forever and the graph is going that side forever also. So in this graph, domain will be all real number. Okay, domain will be all real number, or you can say, sir, I can write minus infinity to plus infinity also. This is also possible. Domain. Now what about range? Now if you look at the y line in the y direction, you can see this is going down forever and this is going up also forever. That means for this function, range is also all real number. Let me draw one graph. Okay, let me draw one graph where both answer. Actually, you can see here all real number. Then you will say, sir, your graph is easy. Your graph is easy. Then what about that? Let me draw one graph where the domain is not all real number, or something is not all real number. Okay, let's extend this side, or else it will suppose this is my graph. Okay, so in this graph, what about the domain and range? Domain is all real number. You can see this side and this side, both sides is going, so domain is all real number, fine. But the range is now different. See, there is some lowest point here. Okay, there is some lowest point. The graph is not going down to this point, so we have to consider this point. Whatever this point is, suppose if this is -1, this is -2, suppose -2, then we will say range is from -2 to plus infinity. Okay, from -2 to plus infinity. Then now range is different. Do you see the difference? If it is going in the both direction forever, then it is minus infinity to plus infinity. Simple answer. But if it has some stopping point, then actually we now have some different thing to consider here. Anyway, so this is how we can find out the domain and range. Now let's try to find out the graph is increasing, decreasing, or what. Okay, increasing, decreasing. Let's find out first local maximum, minimum. First of all, I think this is clear to all of you that in this graph answer will be local maximum, local minimum, because of the arrow sign, open interval. Okay, so now look at this. Okay, let me bring it here. This is what? See, this point is a maximum or minimum. See, the rule is, if it is like this is a maximum. If it is like this is a minimum. Okay, this is minimum point, this is maximum point. This is the rule. So this is the maximum. See, the curve is like this, and then there is a minimum, then there is a maximum, then there is a minimum. Okay, so you see there is a maximum here, there is a maximum here, there is two maximum. This local maximum. Okay, let's write it here. Local max. There is two local max. One is 1 is answer. At minus 3 value 2, at minus 3 value 2, then at 2 value 1. Okay, this 2 is the what? 2 is x value. X value is at, y value is the value. Okay, then local minimum. So local minimum is what? Do you see this? Okay, local minimum. Now local minimum, this point and this point. The problem is I don't have this point here. So basically now I have to count it. Minus 1, minus 2, minus 3. So this is minus 1. This point is minus 1. Then this is 1, 2, 3, 4. Minus 1, comma 4. Okay, this point name is minus 1, comma 4. Minus 1, comma 1, 2, 3. 1, 2. 1, 2, 3. Minus 1, comma minus 3. This point is minus 1, comma minus 3. So we will say at minus 1 value minus 3. Then what about this one? What we will say here? At what? At 4. At x value at 4 value. This is funny, right? Because there is no people here. Still I am asking at what. This is interesting because so that you think when I am saying it, so that you think. That's why I am doing it this way. But this is funny. Anyway, so this is local maximum, local minimum. Now the question is increasing, decreasing. Okay, increasing. First let's find out increasing. Oh, you cannot see. Let's keep it here. So look at the graph first, where it is increasing, where it is decreasing. If you look at this function, the rule is look at from the left side to right side, because the lowest value, the smaller value to the bigger value of the x line. Okay, this way. So you see, if you move from this side to that side, then you hit this point first, then it is increasing. See, it is increasing. You start from looking from the left side. Okay, always for all the graph it will match. Why always from left side to right side? Because this is minus value, then when you move this side, then your x value increases. So we have to go to the x line in the increasing order. There are other methods also, that is true. Okay, there are other methods also, that is true. Okay, let's look at this. So this graph from the minus infinity, this is going to the minus infinity. See, from the minus infinity to 3, minus 3, this is increasing. So increasing, you can write from minus infinity to minus 3. Very carefully see this one thing. We are not writing the y value, we are just writing the x value. Okay, we are not writing the y value. Only for increasing, decreasing, only write x value. Then if they ask you what is the, okay, then this one, see, from this point to this point it is increasing. From this point to this point to this point it is increasing. See, look, this is decreasing, this is decreasing, this point to this point it is decreasing. So we will write the decreasing later. So this to this it is increasing. See, from this side to that side, if you go, see, this is increasing, this is increasing. Always from the left to right, don't forget, always from the left to right. The technique is this, easiest technique is this, or else you have to look at the points, look at the x value, y value, then this will take time. Okay, in exam you do not have time. In real life you have to make quick decision normally. Yeah, so left to right. So see, from minus 1, I said this point name is minus 1 comma minus 3. So from minus 1 to plus 2, then another increasing is from minus 1 to plus 2. This is increasing. Again notice, from this 4 to plus infinity, the graph is again increasing. Do you see this? Do you see? From 4 to plus infinity, this is also increasing. 4 to plus infinity. Normally in one graph there is no this kind of a lot of thing, but in this graph there is many things. That's why just so from 4 to infinity this is increasing. Okay. Now this thing actually you can write in another way also. If you allow me to write it that way also. Look, this one. This don't feel too much scared if I write it this way. So x modulus in terms of, so this way also we can write it. This means what? Minus infinity to minus 3. That means any value which is less than minus 3, any value which is less than minus 3. This means actually that, see, minus 3 is here, this side is any value less than minus 3. So I can write here, if x is less than minus 3, then the graph is increasing. Can I say this? See this. If x is less than minus 3, so suppose minus 4, minus 5, here the graph is increasing. In this section the graph is increasing. Okay, any value where x is less, I am actually writing it from here, any value where x is less than minus 3, the graph is increasing. Then here this also I can write it in this notation system. In this system, this is actually the notation, another notation. So x modulus, here it is what, from minus 1 to 2. So how we will write it? Minus 1, then x, then 2, from minus 1 to 2. This is how we write it. Minus 1 to 2 means this way, minus 1 to 2. Now you can ask, sir, why you are not giving equal to? Because at the point it is not increasing or decreasing. Point is not included in increasing decreasing, because point is constant. After the point it start increasing or decreasing. Okay, last one is what? See, this means what? 4 to infinity means what? 4 to infinity means 4, 5, 6, right? That means any value which is more than 4. Does it make sense? 4 to infinity means what? Any value which is more than 4. 4 to infinity means 4, 5, 6, 7, 8, 9, like this. So that means 4 to infinity means any value which is more than 4. Okay, so let's write it here this way. X is, if x is greater than 4, then this is increasing. So actually same answer I have written in two different style, two different formats, and you need to know actually both of the style, because you never know which one you face when. Okay, then decreasing. Okay, let's write decreasing. Oh my god, I think there is too much writing here. Do you want me to turn the page? Okay, let me turn the page. Or you want to see everything in one page? Everything in one page is good actually, so that you can compare. Let's write decreasing here. Yeah, I think you can see it. Decreasing. Now decreasing only, I think there is only two part here. So you see, from this to this it is decreasing. Okay, from minus 3 to minus 1, right? Minus 1, minus 3 to minus 1. See this part. So this part is from minus 3 to minus 1. This is decreasing, comma. Then another one is decreasing where? See, this is decreasing. This part is decreasing from 2 to 4. From 2 to 4. This two part is decreasing here. In this graph, this two part is decreasing here, because then it is increasing again. So how I can write it this way? So I can write it this way, x, then this is from minus 3 to minus 1. So see, minus 3, x, then minus 1. Finished. This one I can write it this way. Then you need to know this also. You don't say that, sir, if I know this, then I don't need to learn this. You need to know both of the style. Okay, this is important. Both of the, you always in maths or in any other subject, if there is some alternative style, you should know. Okay, we all should know it. Then x, then this is what, from 2 greater than x greater than x is less than actually 4 from here. See, 2 is less than x is less than 4. That means from 2 to 4. From 2 to 4 it is decreasing. If you do not remember, suppose if you don't forget, like, sir, how is it greater? Will this be greater or less? I forgot. How can I do? Then see which number is bigger. 2 is big or 4 is big? 4 is big. So the greater than sign will be to the 4. If this sign is this way, this sign will also be same way. Okay, for all of them, this is true. See, which one is big number? Minus 3 is big number or minus 1 is big number? Which one is big number? Minus 1 is big number, right? That's why the sign will be to the minus 1. Then this sign will follow this. So this is a technique also. Actually, there are many techniques. Once you know, actually you can use all other techniques. So this is how we solve it. Yeah, you can just now have a look at everything once again. You can freeze your screen so that you can once again have a look and check if it is understandable. Thank you all. Thank you very much. I hope it helps, and in the future video I'll try to discuss some more topics. All right, bye bye. I hope it works. I hope it helps. Bye bye.